Hello, everyone. Today, I will introduce how the autonomous mobile locker can be used in the parcel distribution. There are 4 parts. With the development of e-commerce, logistic companies are also booming, which also bring a lot of environmental problems such as traffic congestion, air pollution, and accident. Some city ban trucks from entering the city center. That means logistic companies need to use more small vehicles, which makes traffic congestion worse. And from China's Data Post Bureau 2020 report, the total business volume of parcels reached 83 billion. And from SF Express annual report, they deal with 8 billion parcels last year. In order to deal with more and more parcels, logistic companies need to increase the ability, such as operate new depots or expand current depots and hubs. SF has more than 19,000 depots in mainland China, and we know that the location for the depots are difficult to find in large cities and urban areas. From the map, we can see that in Shenzhen, in a 4.4 kilometers times 3.4 kilometers area, there are 27 depots. This leads to high rent cost for logistic companies. In order to solve the problems in city logistics, we read some papers about vehicle routing problems and the lockers. The vehicle routing problem has been studied for 60 years. Some paper only focus on routing or pickup or delivery, one depot, one echelon, and we expanded the problem to a 2-echelon problem. For locker studies, they focus on the number and the location of the fixed parcel locker, while our study pay more attention on how to use the mobile locker in the logistic network. And sometimes once the depots are established, their location cannot be changed in a short time. Compared with the construction cost, we can change the labor cost and the travel cost to save costs. So we also read some papers about open VRP and the multi-trips problems. And from the traditional pickup and the delivery model, after the courier pick up the parcels from customers, they need to bring the parcels back to depots according to the time window. In our study, we introduced a new pickup and delivery technology, autonomous mobile locker. It looks like a locker, but it has wheels, and it can move automatically. So we can use it to connect the depots and the couriers in the field or for simultaneous pickup and delivery. After parcels are sent to a depot, an AML will take over the delivery process to hand over the parcels to the customers at a meeting point. The point can be outside the community or next to the wall of the building. With couriers taking the parcels for the last mile delivery, AML is free to travel to the next point or back to the depot to pick up more parcels. Therefore, we will use the AML to solve these problems in existing model. For high rent cost, because we can enlarge the coverage of the depots, so we can reduce the number of the depots to reduce the rent cost. For traffic congestion, AML can move on pavement or bike lanes, so they will not lead traffic congestion. And because AML are electric robots, so they will not make air pollution. And compared to other vehicles, AML will use working speed, and it has sensor to adjust the speed. It will be safer. And finally, because it doesn't need a parking space and doesn't need a driver, so this can help us to solve the parking space and the labor cost problem. And based on the previous 2-echelon closed VRP model, we considered add open VRP and the multi-trips in our new model. Open VRP for both echelon. That means the AML will move from one depot to another depot, and same for couriers. They don't need to meet the AML at the same point. And we set the multi-trip only for the couriers, and the couriers can get multiple missions. Our first part study is an AML to Echelon location routing problem, and it plans next day simultaneous pickup and delivery. It's a multi-depot, multi-AML, and a multi-courier capacity to Echelon location routing problem. We built a mixed integer programming model for exact solution. We think about the travel cost, the rent cost of the depot, and the cost of the AML and the points. Our objective is to minimize their total cost. And for the heuristic solution, we based on the hybrid click and write heuristics and add the other elements to build an enhanced version. We test a different number of customers candidated location of the depots and the points, and group A to group C for small instances, and group D for group K for large instances. And as shown in the table 3, the two heuristics had a lower time than the exact solution for all networks. For example, for group A, 11 customers, and the exact solution need 1 to 2 seconds, while the hybrid click and write heuristics need less than 0.1 second, and for the enhanced version is less than 1 second. And we can also observe that the large increase in the time when the time of the in the number of the customer increase from 11 to 21 to 31, and the average time jumped to 28,000 seconds for group C compared to the 1.4 seconds for group A. Therefore, a good heuristics with a reasonable time is needed. And this is an example when we use exact solution and the heuristic solution solve the same customers. And for larger instance, we only use 2 heuristics to test them. We test a different number of the candidate depots and points for 50 customers and 100 customers. And we can find the 3 observations. First, the time increase as the number of the customers increase. And secondly, for each added candidate depot and the 2 points, the runtime increased significantly. And finally, the time of the enhanced version are greater than the hybrid click and write heuristics, will enhanced version produce better solution. And we use the heuristics to test up to 200 customers. And then we did some sensitive analysis. For AML duration, when we increase the duration from half hour to 0.8 hour, we can see that we can reduce the number of the depot to, so we can save the rent cost of the depot. And for AML capacity, when we increase the capacity of AML from 250 kilograms to 500 kilograms, we show we can reduce the number of the AML and the points to reduce the route of the AML to save travel cost. And finally, we did benchmark that when we have AML in the logistic network, we can save 30 to 40% cost compared with no AML in the network. This is an example to show that we need 2 depots in the 1 echelon that we doesn't have AML, and we only need 1 depot in the 2 echelon that we have AML. And our second part study is for AML courier to Echelon open multi-trip vehicle routing problem. We built open VRP for both Echelon, and multi-trip operation happens at the 2nd echelon. So the courier can start multiple missions. And this is the objective objective function. We think that we think about the travel cost and the operation cost of the AML and the courier. We built a mathematical model for variants: single trip closed VRP, single trip open VRP, multi-trip closed VRP, and multi-trip open VRP. And from the result, we can see that for the multi-trip models, we can have better results for the single trip models. And the open VRP model can have better result than the closed VRP model. The difference between the four variants become more significant when the number of the customers increase. And because the exact solution can solve a small instance, the number of the nodes are small. So the result for the multi-trip closed model and the multi-trip open model seems same. So we fix so we set the fixed cost to the extreme value, such as 0. Then we can find that when we focus on the travel cost, multi-trip open VRP can have better result than the multi-trip closed VRP. And finally, there are some key contributions of our study. We introduced a new model for the simultaneous pickup and delivery. We solve multi-depot, multi-AML, and multi-courier to Echelon location routing problem. And based on the hybrid collect and write heuristics, we have an enhanced version to solve the large instance. And we also solve multi-depot, multi-AML, and multi-courier open multi-trip VRP problem. And because we didn't think about a time window in our study, we will take into account for future study to solve the synchronized problem for AML and the courier. And we found that the delivery robot were used to enter the closed management area in Guangzhou at the beginning of the June because of the COVID-19 to deliver food, water, and medicine. And this robot can carry 500 kilograms parcels and run 100 kilometers. If we can cooperate with these logistic companies, then we can test the real data. And the location routing problem part has been published, and we are writing the open VRP with multi-trips part, and we'll submit soon. That's all. Thank you.